The domestic pig, with well-fed individuals often exceeding this weight range. The size and weight of hogs largely depends on their breed. Compared to other artiodactyls, a pig's head is relatively long, pointed, and free of warts. Most even-toed ungulates are herbivorous, but domestic pigs are omnivorous, like their wild relative. When used as livestock, domestic pigs are farmed primarily for the consumption of their flesh, called pork. A group of pigs is called a pasel, a team, or a sounder. The animal's bones, hide, and bristles are also used in products. Domestic pigs, especially miniature breeds, are kept as pets. The domestic pig typically has a large head, with a long snout which is strengthened by a special prenasal bone and a disc of cartilage at the tip. The snout is used to dig into the soil to find food, and as a very acute sense organ. The dental formula of adult pigs is 3.1.4, 33.1.4.3, giving a total of 44 teeth. The rear teeth are adapted for crushing. In the male, the canine teeth can form tusks, which grow continuously and are sharpened by constantly being ground against each other. 4 hoofed toes are on each foot, with the 2 larger central toes bearing most of the weight, but the outer 2 also being used in soft ground. Most domestic pigs have rather a bristled sparse hair covering on their skin. Although woolly-coated breeds such as the Mungalitsa exist, pigs possess both a pocrine and eccrine sweat glands, although the latter appear limited to the snout and dorsonasal areas. Pigs, however, like other, hairless, mammals, do not use thermal sweat glands in cooling. Pigs are also less able than many other mammals to dissipate heat from wet mucous membranes in the mouth through panting. Their thermoneutral zone is 16 to 22 degrees Celsius. At higher temperatures, pigs lose heat by wallowing in mud or water via evaporative cooling. Although it has been suggested that wallowing may serve other functions, such as protection from sunburn, ectoparasite control, and scent marking. Pigs are one of 4 known mammalian species which possess mutations in the nicotinic acetylcholine receptor that protect against snake venom. Mongooses, honey badgers, hedgehogs, and pigs all have modifications to the receptor pocket which prevents the snake venom alpha neurotoxin from binding. These represent 4 separate, independent mutations. Domestic pigs have small lungs in relation to their body size, and are thus more susceptible than other domesticated animals to fatal bronchitis and pneumonia. The domestic pig is most often considered to be a subspecies of the wild boar, which was given the name Sus scrofa by Carl Linnaeus in 1758. Following from this, the formal name of the domestic pig is Sus scrofa domesticus. However, in 1777, Johann Christian Polycarp Erxleben classified the domestic pig as a separate species from the wild boar. He gave it the name Sus domesticus, which is still used by some taxonomists. Archaeological evidence suggests that pigs were domesticated from wild boar in the Near East in the Tigris Basin, Kayonu, Kafahoek, Nawali Kori being managed in the wild in a way similar to the way they are managed by some modern New Guineans. Remains of pigs have been dated to earlier than 11,400 years ago in Cyprus. Those animals must have been introduced from the mainland, which suggests domestication in the adjacent mainland by then. There was also a separate domestication in China which took place about 8,000 years ago. DNA evidence from subfossil remains of teeth and jaw bones of Neolithic pigs shows that the first domestic pigs in Europe had been brought from the Near East. This stimulated the domestication of local European wild boar, resulting in a third domestication event with the Near Eastern genes dying out in European pig stock. Modern domesticated pigs have involved complex exchanges, with European domesticated lines being exported, in turn, to the ancient Near East. Historical records indicate that Asian pigs were introduced into Europe during the 18th and early 19th centuries. In August 2015, a study looked at over 100 pig genome sequences to ascertain their process of domestication, which was assumed to have been initiated by humans, involved few individuals, and relied on reproductive isolation between wild and domestic forms. The study found that the assumption of reproductive isolation with population bottlenecks was not supported. The study indicated that pigs were domesticated separately in Western Asia and China, with Western Asian pigs introduced into Europe, where they crossed with wild boar. A model that fitted the data included a mixture with a now extinct ghost population of wild pigs during the Pleistocene. The study also found that despite back-crossing with wild pigs, the genomes of domestic pigs have strong signatures of selection at DNA loci that affect behavior and morphology. The study concluded that human selection for domestic traits likely counteracted the homogenizing EFF